Hello and welcome to this lecture. Today I'm going to discuss about the regression problem, and in previous lecture we talked about the classification method that which label in those problems were discrete. Now in this lecture we would like to talk about other problems in the machine learning area which has the regression method. Before we were familiar with the linear regression model. Today we implement it and also other methods such as support vector regression, decision tree regression, and random forest regression. In the end, we will implement it using Python. So in the introduction, the regression analysis is a fundamental concept in the field of machine learning. It falls under supervised learning, wherein the algorithm is trained with both input features and output label. It helps in establishing a relationship among the variable by estimating how one variable affects the other one. Imagine your car shopping and have decided that the gas mileage is a deciding factor in your decision to buy. If you want to predict the miles per gallon of some promising ride, how would you do that? Well, since you know the different feature of the car, for example, weight, horsepower, and displacement, etc., one possible method is regression. It means that by plotting the average mile per gallon (mpg) of each car given its features, you can then use regression techniques to find the relationship of the mpg and the input feature. So let's have a look to simple linear regression. In the previous lecture, logistic regression course, we talk about linear regression and the different type of it. As a reminder, here is the formula of simple linear regression. So in simple regression, defined as follow equation, y equal to mx plus b, where m and b are the variables our algorithm will try to learn to produce the most accurate prediction. Here, x represent our input data and y represent our prediction. In this figure, we can see that the model fit the best line on the training data. Here you see the model will try to fit the best line on the training data, and you have to adjust these two variables m and b, the variable that our algorithm will try to learn to produce the most accurate one by adjusting these two variables. Support vector regression, or SVR. Support vector regression uses the same principle as the SVMs. The basic idea behind the SVR is to find the best fit line. In SVR, the best fit line is the hyperbola that has the maximum number of the points. You can see in the figure there is two decision boundary here, decision boundary and decision boundary, and the hyperplane try to maximize the number of points. Means that the best fit line is the hyperplane that has the maximum number of points. Consider these two red lines, decision boundary, and the green line as a hyperplane. Our objective means that when we are moving on with SVR is to basically consider the points that are within the decision boundary line. Our best fit line is the hyperplane that has a maximum number of points. Maximum number of points. Unlike other regression models that try to minimize the error between the real and predicted value, the SVR tries to feed the baseline within a threshold value. The threshold value is the distance between the hyperplane and boundary line. Here you have to take care of this issue. Decision tree regression. We introduced the decision tree for classification problems in previous session. So as we said, this algorithm used for classification and regression like SVM. For instance, suppose we have to predict blood pressure by using some features such as age, gender, and BMI. Like decision tree for classification, to create this separation, the algorithm tests various splits, attempting to maximize information gain by reducing entropy. The answer for each node calculated from all nodes that locate on that. After building the tree, now we can pass a new example and predict their output. You see this figure? We have a data set for predicted blood pressure, and we use like a decision tree to increase this separation. The algorithm tests various splits. For example, this split if age greater than 52, 25, and if age greater than 25. Then they go, and then at the end they will reach to, or after building the tree, we can pass it in a new example and predict their output. So here's the predict of output. Then they new sample. For example, we arrive the age 44 and the BMI is 27, and that the predict value is BP is 1 to 1. Here is the way that this tree or decision tree regression can do for us. Okay, now it's time to focus on another regression, random forest regression. Random forests harness the simplicity of decision tree and the power of ensemble methods. Random forests, if you look at this picture, when you give it data, they train multiple models and they vote to predict. They work by applying many decision tree across new subset of the data. Here in this figure, we have sample data that build many decision trees on data. In the last step, the result obtained through voting. Here, I told you after the applying many decision tree, the result go for voting to predict. For example, the new example show it here. In the new example, you have age, BMI, exercise, smoker, and blood pressure. And our target is to predict the blood pressure. So for example, decision tree 5, 1 apply, and the decision tree 2 apply, and the output, for example, is 131. Decision tree 3 apply, and decision tree n, for example, apply. The final prediction after the voting, it should be 134.25. So that is why they said they have to vote from the all train model, multiple models from the system. After you learn about the regression model, now it's time to focus on metrics or metrics for evaluation model. For the implementation, we need to evaluate the model by, for example, MAE, mean absolute error. The MAE formula is equal to n divided by 1 divided by n multiply sigma y index I minus x index I from I to 1 to n. It means that from this formula, the y index I is our prediction, xi is our true value, and n is total number of data points. Another formula for evaluation is R2. The R2 also came from this formula, and then R2 equal to 1 minus RSS divided by TSS. What is RSS? Sigma yi minus xi power 2, and TSS is sigma yi minus y hat power 2. The yi equal to prediction and xi is true value, and like the previous MAA is the total number of data point, and y hat is mean value of sample. So this is what we have to do in order to get the R2. This is the important formula, MAE and R2. So let's go to implementation parts and how we give the data to our regression model and which regression we apply, and different regression model we already apply here, and we want to show you how to get the data and get the result. So for implementation, you have to import the library. For example, I import NumPy, SNP, and import regression model as well. For the regression models, I teach you SPR, decision tree regression, or linear regression, random forest regression. From scikit-learn.spm, import SPR. From scikit-learn.tree, import decision tree regressor. From scikit-learn.linear model, import linear regression. And from scikit-learn.ensemble, import random forest regressor. After this, you have to import the metrics for evaluation. The metrics is from scikit-learn.metrics, import mean square error that I teach you here, MAE for example, and R2 score. These two score for the evaluation of our regressor. And also for train and test split, you have to catch from scikit-learn.model selection, import train and test split, and for matplotlib, you have to put matplotlib.pyplot as PLT. Now the important import library is finished. Now the next step is preparing the data. For preparing the data, we will use randomly generated regression data. Means that we didn't read any real data set. We just generated some random data set as a target data to fit. Here we can write simple function to generate the data. To do this, we use a sinus function plus a function distribution that you can see in this figure. Here is the function that randomly take 500 sample, for example, and this one is a function make data, and here is a sin x plus np.random unit from the -5, for example, minus 0.5 to 2. They will generate this data, 0.2 to generate this data. And also here I make it a blue color. The generation of the data shows in the blue scatter plot. So very simple. For example, we have this data as a input variable. So after you generate the data set using the random function, now it's time to split the data and then take the 20% of data as a test size. So here we use data set equal to train test split x and y and test size 0.2. So after you create the split data, it's time to build your linear regression model and prediction. So as I mentioned to you, first we implement linear regression on data. We use linear regression from scikit-learn that we imported before. Then fit the linear model on training data. We pass training data and train mode label to the model.fit. Finally, we predict label of the task data by using the model that was learned. Here you can see the real data and predicted data. So after visualization. So here we already discussed, and this is the original data and fitted data and fitted curve that you can see here. So this is the simple linear regression for this issue. So next step is to calculate the metrics. For the metrics, we already imported R2 and mean square. You can see that after implementation, the R2 is 0.39 and MSE or 0.21. So next step is to implement the SPR prediction. So in order to build the SPR model like the previous one, we already recover SPR as SPR.fit train data and train label, and we use ypredict equal to SPR.predict test data. After visualization, you can show them the R2 and MSE how they fit to this one. In previous section, you see the linear regression is not too accurate because our data is like the curve one, and now SPR is more accurate. You see the R2 is very good accuracy, and MSE also very good accuracy. Now let's have a look to decision tree regression and prediction. First, you have to create the object of the decision tree class. Here is the object. Like the previous one, you create the object of the SPR. Here your object is DT model, decision tree regressor, for example, random state equal to 0. Some parameters you can learn from help. And next step is fit it on the data. We have to fit on the data here. Here also you can use the same for this section. Here is a fit on the data. Here also they fit on the data, train data and test data. So here I can put it here in order to make it easy for you. So next step is to use the prediction. You put ypredict equal to DT model prediction. Here also we put ypred equal to SPR.prediction. So next step is to visualize the data, visualizing by using plot scatter or scatter plot, and test data, test label, and test data ypred. And after this you have to put legend and show. So after you calculate the RMSE and R2, you will reach this value, and it seems that our original data is blue color and the fitted data is red dots, that they will reach to this value. Let's have a look to this one is 0.87, 0.04. Now here is 0.6. So it seems that almost same, but let's have a look to random forest prediction. Again, you have to create an object of the random forest RF model, then random forest regressor with this argument. You put it estimator, for example, equal to 3. Fit it on the data. You put RF model fit, train and test, and then next is prediction. Ypred equal to RF model predict. So visualization, you have this section for visualization, and next is calculate the metrics R2 and MSE. So after you get the result, it seems that this value is more accurate than the previous one, and MSE also is 0.06. So you have to compare and see which regression are the best for your model prediction, if you want to write a paper or if you want to report your task for the paper or publication. Thank you so much for your attention.